Yes, good evening once again. The last time हमने लॉज ऑफ मोशन के कुछ न्यूमेरिकल्स देखे थे. सो कुछ न्यूमेरिकल्स बाकी है, शायद 4-5 न्यूमेरिकल्स हम आज कर देंगे फटाफट. Yes, so we can just see the screen. Okay, so we have seen 8th numerical. Let us see the next one. Yes, 9th one. Here. Okay, just read the question carefully. While decreasing linearly from 5 Newton to 3 Newton, a force displaces an object from 3 meter to 5 meter. Calculate the work done by this force during this displacement. Okay, so that means while decreasing linearly, what does it mean is the force is decreasing and the graph of force is going to be a line, straight line. ये उसका मतलब होता है. So let us try to draw the graph between force and displacement. So here we can see the graph between force and displacement. Suppose we take y-axis and x-axis like this here. Suppose x-axis पे हमने displacement डाल दिया और y-axis पे force. Okay, so this is the y-axis and it is given that while decreasing linearly from 5 Newton to 3 Newton, that means there is a force of 5 Newton on the y-axis here. You can just express it as 5 Newton here. Okay, ये 5 Newton का force है और यहाँ पे 3 Newton एक यहाँ पे एक point होगा जिसको हम बोल देंगे 3 Newton force. So that means the force is going to decrease like this linearly from 5 Newton to 3 Newton. Okay, an object from 3 meter to 5 meter. So what does it mean is the displacement made by the object is going to be from 3 meter to 5 meter. तो मतलब ये जो object है वो यहाँ पे 3 meter distance पे start होता है. This is the distance 3 meter here and this is the distance 5 meter here. Okay, so the object starts from 3 meter, but the force at that time is going to be 5 Newton actually. And when the force becomes 3 Newton at that time, the displacement of the body becomes 5 Newton like this. So that means the situation is like this, in which we can just see that the force goes on decreasing linearly and it starts from this 5 Newton and ends up at 3 Newton. But the displacement starts from 3 Newton as you can see here and it ends up at this 5 meter. तो डिस्प्लेसमेंट जो है वो 3 मीटर से 5 मीटर तक बढ़ने वाला है, जबकि फोर्स जो है वो 5 न्यूटन से 3 न्यूटन तक कम होने वाला है. This is the graph between force and displacement. We can just see here, and we want to find out the work done. Okay, so work done by this force during this displacement. So how can we get that? We already seen in the theory that the work done by the force is always equal to the area under the curve, area under the force and displacement graph. तो force और displacement के बीच में जो ग्राफ बनता है तो उसका अगर हमने एरिया निकाल के दिखाया तो that area will give us the work done indirectly. So let us drop a perpendicular from this point on this x-axis, from this point also on this x-axis here, so as to meet here at 3 and 5 in this way. So we want to find out this area here. how can we get this area here? What is this shape called? देखो इस shape को क्या बोलना है? This shape is called as a trapezium. Just say trapezium because the two sides are already parallel. ये दो जो vertical sides है हम देख रहे हैं यहाँ पे, ये दोनों already parallel है और बाकी दो sides जो है वो parallel नहीं है. So whenever there is a trapezium, if suppose there is a trapezium like this, ये suppose हमारे पास एक trapezium है जिसमें ये दो sides parallel है, but बाकी दो sides जो है तो वो parallel नहीं है. तो ऐसे वाले trapezium का area कैसे निकाला जाता है? What is the formula for area of a trapezium? So suppose that its sides are like A and B, and suppose that the height of this trapezium is supposed to be h. Suppose यहाँ पे height हमको यहाँ पे draw करना होगा, and this height is considered to be h here. So अगर इस height को हमने h बोल दिया, तो area of this trapezium is actually given by the formula. See here, half into the sum of parallel sides into the height of this trapezium, that is h, which is the distance between these two parallel sides actually. So this is basically the area of trapezium. So if we just consider this as a trapezium, then its first side, vertical side, has its length that is of 5 Newton, correct? Hai? And similarly, the second side here is going to be having the length of 3 Newton here, correct? Hai? And at the same time, the height of this trapezium, if we just consider this trapezium to be this to be made up of two parallel lines which are vertical like this, then we can just see the distance between these two parallel lines is going to be the height of this trapezium, which is going to be actually 2 here, 2 meter, which is 5 minus 3 actually. So this is going to be the height of trapezium. Then we can just get the area, or we can just say that the work done by the force is always equal to the area under Fs curve or graph. Okay, work done is always equal to the area under Fs graph. So now in order to find out this area, we can just consider it as a trapezium and get its area as half of sum of parallel sides, that is 5 plus 3, and that is multiplied by the height of this trapezium, which is going to be 2 here. So if we just cancel out this 2 from this numerator and denominator, then we can just be able to get this sum of 5 and 3, which is actually going to be 8. And 8 joule is actually going to be the final work done by this force. Okay, so we can just find out the work done in this way here. Yes. Or if you find if you don't remember the formula for area of trapezium, then you can just split this trapezium in two parts, one of which will be a rectangle and other one will be a triangle. So this is going to be a triangle and this is going to be a rectangle. Now rectangle has its length equal to 2 meter and breadth equal to 3 Newton. So the area of rectangle would be 3 into 2 plus area of triangle here. Triangle का area निकालने के लिए उसका base जो कि फिर से 2 है no doubt, और उसका जो height है तो 5 minus 3 करेंगे तो वो 2 बन जाएगा no doubt, और इसलिए फिर यहाँ पे उसका जो area है वो हमको मिलेगा half of base which is 2 into the height which is 2 again, and hence 2 gets cancelled and we'll be left with 6 plus 2 which is 8 once again in joule. So in this way we can just find out the work done by this variable force, which varies linearly from 5 Newton to 3 Newton and displaces the body from 3 meter to 5 meter in this way. So this is the simplest method to find out the work done by using the graph. But we have to be able to plot the graph properly, okay, according to the given information. जो given information हमको दिया हुआ है तो उसके basis पे हमको graph बनाने आना चाहिए. Once we draw the graph, we can easily find out the area under the graph, and that is going to be the work done indirectly. Yes, let us see the next question. Yes, this is again a simple question. in which the force is given to be variable. Force is given to depend upon x, and it displaces the body from x equal to 1 to x equal to 2 in the region. Calculate the amount of work done. Total work done we have to find out. And variation of the force in a certain region is given by this equation. So force satisfies this equation. That means force is expressed as 6 times of x square minus 4 times of x plus, minus 8. Okay. So this is the equation of force in terms of displacement. And as this displacement is variable, you can see that the force is also variable. So the work done by such a variable force can only be found out by using the method of integration. So work done is obtained to be integration of f into dx. You have to understand this. Okay, f into dx we have to work out. And that is also from x equal to 1 to x equal to 2. These are the limits of integration. So this is 1 to 2. So 1 is the initial value of x, and 2 is going to be the final value of x. Okay, so integration of f into dx. F is going to be 6x squared minus 4x minus 8 kept as it is, and that is multiplied with dx, and that is from 1 to 2 as it is. Okay, now we can just calculate this integration. So 6 is a constant, can be taken out, and integration of x square can be found out with respect to dx, that is from 1 to 2, no doubt, minus 4 is again a constant, can be taken out, and integration of x only with respect to dx can be found out from 1 to 2 again. In the same way, here minus 8 is going to be a constant, and integration of 1 dx means only dx can be found out, that is from 1 to 2 in this way. Okay, so here we can just see that is 6 as it is, and integration of x square according to the formula for integration, that is x raised to n. Integration of x raised to n dx happens to be actually x raised to n plus 1 upon n plus 1, correct? So n is going to be 2 here in this case. So the integration of x square will happen to be x cube upon 3, okay, and that is from 1 to 2 as it is. Then again minus 4 times of x dx. X raised to 1 is here, so x raised to 1, 1 is going to be n, so x raised to n plus 1 becomes x raised to 2 upon 2 as it is, and that is from 1 to 2 kept as it is, minus 8 into, here it is dx. Dx का integration क्या होता है? Simply x, that is from 1 to 2 again. So in the next step we can just have this simplified as, here we can just take this 3 out, and this 3 can get cancelled with this 6, leaving behind 2 outside. Here, even here 2 can also be cancelled with this 4, leaving behind 2 outside, and then we can just be able to get this as 2 times of simply the integration of x cube from 1 to 2 minus 2 times of integration of x square from 1 to 2 and minus 8 times of integration of x, 8 into x जो है, that is from 1 to 2. Okay, so now we have to put the limits, lower limit and upper limit. जहाँ पे भी x दिखता है वहाँ पे हमको 2 डालना है पहले, और फिर उसके बाद 1 डालना है and subtract करना है. Let us see what happens. So it becomes 2 cube minus 1 cube. Okay, in the first term minus 2 times of, here it is going to be 2 x square का हमको वैल्यू निकालना है 2 और 1 डालने से, तो ये 2 का स्क्वायर माइनस 1 का स्क्वायर, करेक्ट है, and then finally here it is going to be 8 times of 2 simply minus 1. That's it. So if we just try to find this out, then we can get is 2 into, here it is 2 cube is 8 minus 1, which comes out to be 7. Then here 2 times of, here 4 minus 1, and minus here 8 times of 1 simply. So if we just solve this further, then we can get this 2 into 7 minus 2 into 3 here, and minus 8 kept as it is. So here it becomes 2 into 7 can be written as 14. So here it becomes 14 minus 6 minus 8. That is becomes 0 actually. 0 joule. Okay. So this is actually going to be the work done. Okay. Actually, we can just avoid all these steps. ये सब जो steps हमने किए ना यहाँ पे वो सब avoid कर सकते हैं आराम से, because we know that the integration of this 6x square minus 4x minus 8 dx from 1 to 2 can be simplified in a single step. That is, तो एक ही स्टेप में हमको मिल जाएगा ये 6x स्क्वायर जो है उसका इंटीग्रेशन डायरेक्ट हम निकालेंगे. 6 इज अ कांस्टेंट एंड x स्क्वायर का इंटीग्रेशन बनता है x क्यूब बाय 3. सो वी कैन जस्ट गेट इट एज 6x स्क्वायर क्यूब अपॉन 3. Okay, minus 4 is a constant once again can be taken out and is x only. x का इंटीग्रेशन क्या बनेगा x square by 2 जो जैसा कि हमको पता है. So here it will be x square by 2, no doubt. And 8 is again constant and dx का इंटीग्रेशन क्या बनता है simply x. That's why we can just get this as minus 8x. That's it. And that is from 1 to 2. And then we can just in the next step have to substitute 2 here. First of all, just cancel out this 3 with 6. Cancel out this 2 also with 4. So as to be left with 2x cube minus 2x square minus 8x. That is from 1 to 2. And then in the next step, we can just have this simplified as by putting x equal to 2 first in the whole bracket. जहाँ पे भी हमको x दिखता है इधर इधर और इधर हमको पहले 2 डालना है, उससे फर्स्ट ब्रैकेट हमारा बनेगा. So you can just get that is 2 into 2 cube means it is 8 here minus 2 into 2 square which is going to be 4 here minus 8 into 2 here which is going to be 16 actually, and then minus sign in between. And then in the next bracket we can just go on putting 1 here in place of x. So 2 into 1 cube which comes out to be 2 only. Then here it is minus 2 times of 1 square which is simply 2 and minus 8 kept as it is. And then we can just try to solve this further so as to get the final answer, which will appear to be same, that is 0 here. Let us check. This is the another part. So here we can just solve this further and get this first term as 16 minus 8 minus 16. And in the second bracket here it will be 2 minus 2 will get cancelled and minus 8 will only be left here in the second bracket. So that in the first bracket here 16 minus 16 just gets cancelled and minus 8 is left as it is, and his minus of minus becomes plus and 8 will be left as it is. So here it will become 0 once again as before. So this is another method in which the number of steps we have to use will be just reduced by using the direct method. साथ अगर simultaneously अगर हम सबका integration अगर निकालते जाएंगे तो उससे थोड़े steps reduce हो जाते हैं, तो that will be more simple. We can just see. Yes, if you have any doubt you can just put it in the chat box, or we can just move to the next question. Yes, let us read this 11th question here. Okay. Just read this question. See here, a ball of mass 100 gram dropped on the ground from the 5 meter and bounces repeatedly. During every bounce, 64% of potential energy is converted into kinetic energy. Okay, so calculate the coefficient of restitution, the first thing. Then speed with which the ball comes up from the ground after the third bounce. Okay, third bounce के बाद कितने speed से वो ऊपर आता है. Then again, impulse given by the ball to the ground during this bounce. Okay, impulse कितना होगा. And fourth is the average force exerted by the ground if this impact lasts for 250 milliseconds. And last is the average pressure exerted by the ball on the ground during this impact if the contact area of the ball is going to be 0.5 centimeter square. Okay, so see here, these are the 5 things we have to find out. So first of all, we have to remember what we have derived for this situation. ये situation के लिए हमने already कुछ formula derive करके रखे हैं, आपको याद होगा सभी को. देखो, suppose this is the ground and suppose the ball just is released from a height h above the earth's surface, and suppose it drops and just hits the ground and returns back. It just reaches to the height, another height, and then again it just goes down and again returns back and again returns back like this. So every time it makes the collision, it loses some of its kinetic energy, and hence the height up to which it rises up after the bounce just get decreased every time. So initial height we can just assume it as a h naught, as we have done it in the case of theory. The height attained after the first bounce can be supposed to be h1, and the height attained after the second bounce can be considered as h2, and in the same way the height attained by the ball after the third bounce, suppose here this is the h3, we can say. Okay, again it is going to repeat the same procedure again and again. Okay, so this is the first bounce, this is second bounce, and this is the third bounce. Okay, यही third bounce है ना. Okay, right, sorry. Okay, so after the first bounce, the height is h1. After the second bounce, height reached is h2, and after the third bounce, the height is going to be h3. Okay, so now we have found out the. अच्छा, सबसे पहले एक बात याद करो कि यहाँ पे ये जो दिया हुआ है कि during the collision, during every bounce, 60% of the potential energy is converted into the kinetic energy. ये दिया हुआ है. What does this mean here is, see, in the first bounce, the 60% of potential energy will be converted into the kinetic energy. Means, suppose that the potential energy of the ball initially is suppose mg h naught. This is the original potential energy, and out of this, इसका 60% जो है, तो इसको multiply करेंगे 60%, 64% से. So this is 64%. तो ये हो गया 64% of potential energy, and that is converted into the kinetic energy. Okay, so this is actually going to be the kinetic energy. But after all, this kinetic energy is used to make this ball rise up to the height h1 here in this case, right? So यही kinetic energy लेके ये ball जो है वो h1 इतने height पे जाएगा, जिसका मतलब ये है कि ये kinetic energy जो है वो actually bounce के बाद का, मतलब collision के बाद का potential energy बनने वाला है. And collision के बाद का potential energy कितना है हमको पता है already. It is going to be mg h1, right? h1 is the height attained by the ball after the first collision. So we can just get that 64% of mg h naught is equal to mg h1. That means 64 upon 100 into mg h naught is actually going to be equal to mg h1. So that this mg gets cancelled, and what we are left with is simply ये इसको भी अगर reduce करेंगे तो हमको मिलेगा 8 by, sorry, reduce किससे करेंगे, 4 से reduce करेंगे तो 4 16 जा and here it will be 425. Okay, that means 16 by 25 is going to be the value of into h naught into is equal to h1. So if you just send this h naught in the denominator in this side here, then we can just be able to get that 16 by 25 is actually going to be h1 by h naught, right? Yes. And now we can just recall the formula for coefficient of restitution in this case. When one body remains at rest and other body just collides and rebounds back, the coefficient of restitution in this case is given by the velocity of the colliding body after collision upon the velocity of colliding body before the collision. And we already proved that this coefficient of restitution can also be written to be same as root of h1 upon h naught, right? So h1 upon h naught ये हमको मिल जाएगा as the coefficient of restitution, and this coefficient of restitution in this case here can be obtained to be simply root of h1, where h1 upon h naught is directly, we can just see that it will be 16 by 25. If we just put its value as it is here, then we can just be able to get this e to be simply 4 by 5, correct? So 4 by 5, or we can just call it as 0.8, no doubt. So this is the value of coefficient of restitution which is asked in this first question here. You got it here. Okay. Now the speed with which the ball comes up from the ground after the third bounce. Now we already derived the general formula for the speed after nth bounce. Remember? याद होगा सभी को? If you just recall the formula for the speed attained by the ball after nth bounce, nth collision करने के बाद ये बॉल का स्पीड कितना होता है, तो वो अगर हम देखेंगे ठीक से, तो it will be actually vn, it is given by e raised to n into v naught, correct है? And v naught means the initial speed with which the ball just strikes the ground. Now that is to be found out here. So in order to find out this v naught, we'll have to work out something. तो सबसे पहले हमको ये करना होगा, v naught निकालना होगा. So in order to find out this v naught, we can just use the conversion of potential energy and kinetic energy between these 2 points here. So if suppose the ball is released from this height h naught, then what kinetic energy it will attain when it will reach the ground is given by the formula mg h naught is equal to half mv naught square, correct? So this is the relationship between the velocity and height h naught. So if we just cancel out this m from both sides, then we can just be able to get this v naught square to be simply equal to, ये 2 इस तरफ भेज देंगे तो हमको मिलेगा 2g h naught, right? And then we can be able to get this v naught to be simply equal to root of 2g h naught. And finally we can just get this v naught to be simply equal to root of 2 into g, which is 10, we can just take it as 10, into h naught, which is already given to be 5. Okay, so if you just put it 5 here, or just take this g as 9.8 into 5, so that we can just take this v naught to be simply equal to root of 2 5s are 10, and 9.8 into 10 becomes 98 here. Yeah, or just you can just take it as 10, so it becomes approximately 100. Okay, approximately it will be 100. V naught is going to be 100, and hence V naught actually happens to be 10 meter per second. And then we can be able to use the formula for nth bounce, velocity after nth bounce. So velocity after nth collision is given by e raised to n into v naught, correct? So here v naught is already given to be 10, and e raised to e is given to be 0.8, or we can just call it as 4 by 5. And since it is given to be after third bounce, so we can just take this n to be 3 here. तो n के बदले हमको यहाँ पे 3 डालना है, और v naught जो है वो तो 10 already है ही. Yes, so if we just find it out, then we can just be able to get this as 4 का क्यूब जो कि बनता है 64 और 5 का क्यूब बनता है 125. Okay, and that is to be multiplied with 10 here. Remember one thing, whenever you see 125, you may remember that 125 multiplied by 8 is always 1000, which is a round figure. Okay, so if you just remember this product for 125, then we can be able to use this here. तो इसको यूज करने के लिए हमको लेकिन क्या करना पड़ेगा, पहले we will have to multiply, divide by 8 to numerator as well as denominator here. तो यहाँ पे हम इसको क्या करेंगे, न्यूमरेटर और डिनोमिनेटर दोनों को 8 से मल्टीप्लाई कर देंगे. So let us multiply this numerator by 8 and here denominator also by 8, so that the denominator becomes round figure, that is 1000, and then 64 into 8 can be easily multiplied. 8 4s are 32, 3 is carry, 8 6 are 48 plus 3 51, and multiplied by 10, so 10 just cancelled, and baki jo bacha 512 upon 100 can actually be written as 5.12, and that is actually going to be the velocity in meter per second after the third bounce, which is the answer of the second question, we can say. Let us try to do this third one here. So impulse given by the ball to the ground during this bounce. Okay, impulse given by the ball. What is impulse? Do you know? We already seen that the impulse momentum theorem, which tells us simply that the impulse exerted by the force is always equal to the change in momentum. Correct? Change in momentum. So that means impulse we have to find out. That means in short, what we have to find out is we have to find out the change in momentum in this case. And during this bounce means actually they are talking about the third bounce only. जो थर्ड बाउंस के बारे में हम बात कर रहे हैं तो उसके बारे में बात की जा रही है. ओके, तो अभी देखो थर्ड बाउंस के बाद का जो वेलोसिटी है वो तो हमको मिल गया, नो डाउट, बट कैन यू फाइंड आउट द वेलोसिटी जस्ट बिफोर द थर्ड बाउंस? सी हियर, थर्ड बाउंस के बाद का जो वेलोसिटी है तो वो तो हमको मिल गया है इधर, लेकिन थर्ड बाउंस के पहले का जो वेलोसिटी था वो एक्चुअली सेकेंड बाउंस के बाद का वेलोसिटी होगा, राइट? तो इसलिए यही फॉर्मूला हमको यूज करना है और सेकेंड बाउंस के बाद का वेलोसिटी निकाल के दिखाना है, so that we can find out the impulse, because impulse requires change in momentum actually. Okay, so here v2 we can just say, ये जो फॉर्मूला हमारे पास है vn is equal to e raised to n into vn v naught. तो ये फॉर्मूला यूज करके हम v2 निकालेंगे. v2 मतलब the velocity after second bounce, which will be the velocity before, just before the third bounce. Okay, yes, so v2 will be actually equal to e raised to 2 into v naught, right? n equal to 2 डाल दिया हमें यहाँ पे, तो v2 will actually be equal to, अभी e का वैल्यू कितना हमको पता है ऑलरेडी, is 4/5. okay, so this is 4/5 और उसका हमको करना है स्क्वायर और उसको मल्टीप्लाई करना है v naught से, और v naught कितना है 10. okay, so this is 10 here. So if you just try to find out v2, then we can just be able to get this as 4 का स्क्वायर जो कि 16 upon 25, and that is to be multiplied by 10 again. अभी 25 के बारे में तो तुमको पता ही होगा ऑलरेडी कि 25 into 4 happens to be 100. So in order to make it multiple of 10, we have to multiply and divide by 4 here. So 25 4s are 100 and 16 4s are 64. So we can just get that v2 is actually going to be equal to 64 upon 100, and that is to be multiplied by 10, which is kept as it is. So 10 का एक 0 और ये 100 का एक 0 कैंसिल हो जाएगा, और जो 64 upon 10 जो है वो हमको 6.4 के फॉर्म में मिल जाएगा. So this will be 6.4 meter per second. This is the velocity after the third bounce, sorry, second bounce, and the velocity before after the third bounce is going to be 5.12 meter per second here in this way. But now we have to find out the impulse. That means we have to find out the change in momentum in short. So let us find it out on a next page. Just record these values. 6.4, v2 is 6.4, and v3 is actually, this is actually v3 here. Okay, v3 means the velocity after the third bounce. Okay, so v3 is going to be 5.12. Just record these values, and just now we can just record here. v2 is actually going to be 6.4 meter per second, which is we have found out just now, and v3 is already been found out, which is going to be 5.12 meter per second. These are the velocities just before and after the third bounce. Now, if you just focus on third bounce, suppose this is the ground, and the ball, suppose sorry, okay, yes, suppose, sorry, yes, suppose we have this ball, ये बॉल है, अभी वो जब नीचे जा रहा है, तो उस समय का जो उसका वेलोसिटी है, वो अभी ये थर्ड बाउंस है. दिस इज गोइंग टू बी द थर्ड बाउंस और थर्ड कोलिजन वी कैन से. सो थर्ड कोलिजन के जस्ट पहले का जो वेलोसिटी है, दैट विल बी एक्चुअली v2 हियर, गेटिंग इट. एंड as soon as it just strikes the ground and just bounce and just starts moving in the upward direction here, तो यहाँ पे वो ऊपर के डायरेक्शन में जाना चालू करेगा. So the velocity of the ball after this third bounce will be called as v3 actually, and we want to find out the change in momentum in this situation. So since the collision, the velocity before the collision is downwards, we have to consider it as negative. This velocity has to be considered as negative, and the velocity after the collision here is going to be upwards, so we have to consider it as positive. Remember, okay? So in order to find out the change in momentum, v3 will be considered as positive and v2 will be considered as negative, and then we'll be able to find out the correct change in momentum. Okay, so here we want to find out the impulse actually, but we know that impulse is actually equal to the change in momentum, and change in momentum is given by the formula the final momentum minus initial momentum. And as we know that the momentum is given by the formula mass into velocity, so we can just get that. Here it is, final momentum, which is the product of mass and v3 actually. Okay, because it is after collision, so इसलिए mass multiplied by v3 will be the final momentum, minus initial momentum is going to be the mass multiplied by v2, but don't forget it is negative, so we can just get this as minus of m into v3, sorry, v2, which then after simplification will become m into v3 plus m into v2. Don't get surprised how this becomes plus, because actually the momentum before the collision is downwards and the momentum after the collision is upwards, so they are just opposite in signs. So when we just subtract those two numbers which are opposite in sign, actually they get added up together. So that's why they will just add up together. Actually they are not numbers, actually they are vectors. So vectors हम add कर रहे हैं, but vectors के बारे में भी वही logic use हो रहा है कि vectors are opposite in directions and we want to subtract them. So when we try to subtract the two vectors which are opposite in direction, actually they get added up together. Their magnitudes get added up together. So here we can just get this m common, and what we are left with is v3 plus v2 in this bracket. And then we can just be able to get this m, which is actually given in the question. Let us see, 100 gram. Okay, 100 gram. So just put it here, 100 gram. That, but again, just convert it into kilogram. And we know that 100 gram means 0.1 kilogram. So we can just put it as 0.1 kilogram. And then we have to multiply it by v3 plus v2, where v3 is going to be 5.12, as we already found out. And v2 is already, sorry, v3 is already 6. Sorry, v3 plus v2 now. Okay. Okay, so V3 is actually 5.12 and V2 is actually 6.4 here. So if we just add these two, then we can be able to get this 0.1 into, what is the addition? It's going to be 11.52. Yes. And if you multiply this by 0.1, then the decimal point will just get shifted one digit at the left side. So as to become it as 1.152. And as we know that momentum is measured in kilogram meter per second. So this impulse will also be measured in kilogram meter per second only. Or we can just call it as joule second, which is another unit of impulse. Okay. So either we can call it as 1.152 kilogram meter per second or 1.152 joule per second. Let us see what they have done. Yes, 1.152 Newton second. This is the answer of the change in momentum, that is impulse. Okay, let us try this fourth question. Average force exerted by the ground if this impact lasts for 250 milliseconds. That means time is given here. So we already know that according to the Newton's second law of motion, the force is simply the change in momentum upon time. Correct? Hai? So change in momentum divided by time will give us the force, right? So if we just have this change in momentum replaced here, which we already found out it as 1.152. So just put it here in the numerator. So this is 1.152 in the numerator and denominator will be time. What is the time? It's already given to be, see here, it is 250 milliseconds. Okay. So 250 milliseconds, you have to replace it here. But don't forget that this 250 milliseconds, millisecond has to be converted into seconds because millisecond is not a standard unit of time. So 250 multiplied by 10 raised to minus 3. Milli matlab 10 raised to minus 3. फिर वो second हो या gram हो या कुछ भी हो. So here it will be force which is going to be equal to 1.152 upon 0.25. It will be here. After multiplying this 10 raised to minus 3 here with this 250, the point will just shift 3 digits at the left side. And hence we can get this as 0.25. Yes, 0.25. Now, again, remember that this 0.25 multiplied by 4 is actually 1, correct? 25 into 4 is 100. So 0.25 into 4 will be 1. So we can just multiply denominator and numerator by 4 each. So as to convert the denominator to be a round figure, that is 1. So here it will be 1. And in the numerator, we'll have to multiply this 1.152 with 4. So that we get this 4 2s are 8. Here 4 5s are 20 to carry. 4 1s are 4 2 6. And here it will be 4 only. Okay. So finally, the force is actually going to be 4.608, and that is going to be in Newton actually. So we have got this force. Okay, which is the answer of this next fourth question here. Okay, let us go to the next here. Average pressure exerted by the ball on the ground during the impact if the contact area is given to be 0.5 centimeter square. Okay. So अगर एरिया दिया हुआ है तो प्रेशर निकालने में कौन सी बड़ी बात है? Pressure is actually defined as the force upon area. So pressure will be actually force, which is expressed in Newton, that is 4.608, which is to be divided by area, which is actually 0.5 centimeter square. Okay. So 0.5 centimeter square, but we are not, remember that this centimeter square, 1 centimeter square is always equal to 10 raised to minus 4 meter square. And then we can just be able to put this value here so as to convert this centimeter square into meter square, so that we can get this as 0.5 into 10 raised to minus 4, and that then it will be in meter square. So if we just take this 10 raised to minus 4 in the numerator, then we can be able to get this as 4.608 into 10 raised to plus 4. Okay, 10 raised to minus 4 goes up and becomes 10 raised to plus 4. And 0.5, which is left as it is in the denominator. And as we know that this 0.5 into 2 is actually 1, correct? Let us divide by 2 here, to numerator as well as denominator, so that in the denominator we can just have this round figure, that is 1, and in the next step we can just have this 2 multiplied with this 4.608, which comes out to be 8 2s are 16, 1 carry, 1 as it is, and 2 6 are 12, 1 carry again, 2 4s are 8 plus 1 9, and hence we can just get this as 9.216 divided by 1, and that is again, don't forget that it is multiplied by 10 raised to 4, which shifts the decimal point, the 4 digits at right side. So if we just shift the decimal point 4 digits right, then we can just be able to get this as 92160. See, the decimal point was at this point here, 1 2 3 4. Here it will be the decimal point. That means 0.00 कितने भी लगा लो, इसमें से कोई फर्क नहीं पड़ता, but we can just have this as a final answer, which is going to be in Pascal, or we can say Newton per meter square, okay, which is the standard unit of pressure, Newton per meter square. Let us see, 92160. Yes, 92160. That means 9.216 into 10 raised to 4 Newton per meter square, which is the answer of this 5th question here. Okay. If you have any doubt, just put it in the chat box. Or we can just go to the next question. Okay. Next question, we'll do it tomorrow in the next lecture. Okay, so let us stop this lecture here. Thank you, all of you.